All right, so this video is going to go over your circular motion review. So before we start, I kind of want to just make sure we're going to pretend like you really haven't kind of seen this before. We're going to kind of start a little bit from the beginning, not totally. But things you're looking for when you are looking at a problem are things like your period, which is the time it takes for one revolution. So that's your capital T. Okay, so again, that's period. It's the time for one revolution. Now the opposite of that is frequency. Frequency is your lowercase f. That is how many rotations happen in 1 second. Okay, so we start off with our equations. T equals 1 over f, and then f equals 1 over t. Okay, so they are inverses of each other, so that's why you can do that. But you can also know that these can just go back and forth, so you don't have to try to memorize two equations, which will give you one of these. But just know that those t and f can go back and forth. Okay, then we're going to deal with things like your radius. Okay, so radius is going to be the distance from the center of the circle to the wherever the object is, and that has to be in meters. Okay, so usually if you don't see it in meters, usually it's in centimeters. So remember, there's 1 meter equals 100 centimeters. So if it's in centimeters, you're going to divide by 100 to fix that. Okay, so your radius has to be in meters. Now, 9 times out of 10, anytime you see a distance in your problem, that's going to be your radius. Only time it may not be is if you see the word diameter. And if you see the word diameter, you just need to split that in 2, and then you have your radius. Okay, then you have your velocity. Okay, you may see terms like speed as well. It's the same thing. Okay, it needs to be in meters per second, which honestly, once you fix your radius in meters or your time in seconds, you don't have to really worry about converting your velocity. Okay, and then you have your acceleration. Okay, that is going to be in meters per second squared. Those are your units for that. So that's centripetal acceleration. And then you have your force. Okay, so force is going to be centripetal force, and that's going to be newtons. Okay, that's your units for force. Okay, and then the last thing is going to be your mass. Okay, so mass is going to be in kilograms. So remember, for 1 kilogram, there is going to be 1,000 grams. Okay, so if you see something in kilograms, so if I saw 2 kilograms and you want that in grams, which you wouldn't, you'd multiply by 1,000. Okay, or if I saw something like this, if I saw like 500 grams and I need it in kilograms, you're going to divide that by 1,000. Okay, now your equations you're going to see is when you're dealing with velocity, force, and acceleration is going to be, first of all, is v equals 2 pi r over t. Okay, r would be your radius, t would be your period, the time for one revolution. Okay, so just be careful with this. That is a very specific time. That is the time for one revolution. That is not just time in general. Okay, so like an example would be like this problem right here, which we'll do here in a bit, is you see 9 revolutions every 5.25 seconds. Now, while that is a time, that is not the time for one revolution. You would need the time for one revolution, so we would find that, which we'll do that here in a bit. And then you have your centripetal acceleration equation, which is v squared over r. Okay, so you take your velocity and square it and divide it by your radius. And then you have your last equation, Fc, which is your centripetal force, which is mass times your centripetal acceleration. Okay, so those are your 3 main equations, and just know that you can use these to go back and forth. You can find something here to use here, and then move on to here, or vice versa. You can find something here that you need, like if you need this AC to help you over here, you can plug that in here. So you gotta think of it like a puzzle. So the trick is going through your problems and looking at what you have, and then figuring out what you can do. Now, your period equations, we see T equals 1 over F. There's also some different variances. You can do your time divided by your total number of revolutions. Okay, so the example I use is if you have like a 6-minute mile and you want to know how fast each lap is. Okay, well, you're going to take your 6-minute mile and divide it by the number of laps, which is 4, and that comes out to a 1.5-minute lap pace. Okay, so that's how you can find your time. Or if you see something like RPMs. Okay, RPMs, so you can do T equals 60 over RPMs. Okay, so there's 60 seconds in a minute, so that makes sense as if you would take 60 seconds and divide it by the rotations per minute. That's how you find out how long it takes for one rotation, which we're about to do a lot of this here in this video, but I just want to kind of do a real quick recap. So let's go up here and start on number 1. So a car is driven around a curve with a radius of 320 meters, so that is R, and it's in meters, so we're good. Then we're going to move on. Then another curve with a radius of 960 meters, so there's another R, and it's in meters, and we're good. Okay, in both cases, the speed of the car is 28 meters per second. That is your velocity right there. What is the centripetal acceleration in each case? That means you're looking for AC. That is your question mark. So these problems can get really difficult if you're not able to label what you have. If you don't know that meters is radius, okay, that's going to be a little difficult. If you don't know that meters per second is your velocity, that's going to make it a little difficult. Okay, so you need to make sure you can do that. So I'm looking for AC, and we know our main equation is AC equals V squared over R. So AC equals V squared over R, and I have velocity, I have radius, so we're just going to find the AC for each situation. So we're going to do our V squared, which is 28. 28 squared over your R, which is 320. Okay, so this is going to be your first scenario. So 28 squared divided by 320 is going to give you an acceleration of 2.45 meters per second squared. So there's your first answer. Then I'm going to do it again to find out what my acceleration in the second curve is. It's going to be 28 squared over my radius, which is now 960. Okay, and I'm going to get an acceleration of 0.82 meters per second squared. So if you notice this, when you make that radius bigger, okay, that acceleration is going to go down. Number 2 is a 0.013 kilogram mass, so there's your mass, is attached to a 93 centimeter length. So again, length is your radius. They don't mention anything about diameter, so I don't need to split it in half or anything. Okay, but if you do see this is centimeters, and you can't have that. So remember, there's 100 centimeters in a meter, so 93 divided by 100 is going to give you 0.93 meters. So that is your radius. Okay, and it's swung in a horizontal circle that makes one revolution in 1.18 seconds. That is your time, okay, your period. Okay, I'm seeing a lot of people that are taking times and they're trying to plug it into this whole T equals 1 over F or 60 over RPMs. Okay, big T is the time for one revolution. If I told you that one revolution equals that, that is your big time. So don't make it harder than it is. Okay, you don't need to do any more with that. That is your big T. Okay, so let's clear that up over here. Okay, so what we're going to do is we're going to find the speed of the mass. That means we're looking for velocity. Now our first equation for velocity is V equals 2 pi R over T. I have radius, I have T, so all I gotta do is plug in. So 2 pi, your radius is 0.93, and your time is 1.18 seconds. Okay, so do your math there, and you should get 4.95 meters per second. So there's your answer for A. B, find the mass's centripetal acceleration. So we're gonna look for AC. So AC equals V squared over R, and now I have V right here. So we're going to take that 4.95 and we're going to square it and divide it by our radius, which is 0.93. Okay, just be careful. Don't take this T right here and put it on bottom. Just because it was on bottom there doesn't mean you need to bring it down here. Okay, make sure you're looking at the difference between these equations. V uses T on bottom, AC uses R on bottom. Okay, so just be careful of that. It's really easy to make that mistake. Okay, so that's just kind of a heads up. So 4.95 squared divided by 0.93 is going to give you an acceleration of 26.35 meters per second squared. Now, C, find the tension force in the string. Okay, so force, your centripetal force is FC. So anytime you see the word force, we're looking for F. Okay, so FC just means centripetal. Okay, so equals mass times your centripetal acceleration, which now I have my acceleration. So my mass was 0.013 times your acceleration, which is 26.35. We're just going to multiply those, and you're going to get a value of 0.34 newtons. Number 3, Phil puts his favorite Backstreet Boys disc in the CD player if it spins with a frequency of 1,800 revolutions per minute. So I just gave you 1,800 RPMs. Okay, what is the period of the spin of the disc? That means I'm looking for big T. I want to know how long it takes just for one spin. So you can do T equals 60 seconds divided by the RPMs, which would be 1,800. Okay, so 60 divided by 1,800 is going to give you a time of 0.033 seconds, and that is all you had to do. Number 4, Roxanne is making a strawberry milkshake in her blender. A tiny 0.0050 kilogram strawberry is rapidly spun around the inside of the container. So there's your mass. Okay, with a speed of 14 meters per second, there is your velocity. And it's held by a centripetal force of 10 newtons, so there's your FC. What is the radius at this location? Okay, so you're looking for R. Now, if you kind of see this question and you're like, what the heck do I do here? Okay, you need to look at your equations and figure out which one has R in it. We've got 2 of them. You got V equals 2 pi R over T, and you have AC equals V squared over R. Okay, so I'm going to look at both of them. Do I have a velocity? Yes, I do. Do I have a time? I do not. So that means I really can't use this one right now. AC equals V squared over R. Do I have an AC? No. Okay, do I have a velocity? Yes. Okay, so I really can't use this one. Okay, so that means I'm missing something from one of these equations. Okay, I need to either find T or I need to find AC to help me out. Now, if you notice, I gave you FC, force, and I gave you mass. If you look at your third equation, FC equals mass times AC, okay, a good hint is that anytime I give you enough to do an equation, you're probably going to need that. Okay, so I can plug the 10 in here for FC. I can plug in my mass, 0.0050, and I can look for my AC, so I can find my AC. Okay, and I'm going to get an AC value of 2,000 meters per second squared. Okay, because if you notice, what I can do now is I can take this AC and I can bring it over here to help me out to find my R, because now I have my AC, so I'm good here, and I have my velocity, which is right here, so I have both of these, so now I just got to solve for R. Okay, so AC is going to be 2,000 equals V squared over R, so my velocity is 14 squared over R. So remember, anytime there is a variable on bottom, you can just switch these two. So it's 14 squared divided by 2,000, and you're going to get a radius of 0.098 meters. Okay, and it is okay to have a small number like that because we're using meters and we're talking about a blender. Okay, blenders aren't that big, so it should be a very small radius. Okay, so that's how you solve for that one, by using this equation to help solve for AC and bringing it over to this equation. Okay, number 5, a 0.5 kilogram object. So here's your mass. Okay, and then what I'm going to do is let me clear up some of this down here so we have some room. Okay, and then feel free to rewind this and stuff if you need any of this. Okay, so we're going to solve for this. So I have a mass of 0.5 kilogram object is moving in a horizontal circle at the end of a 0.60 meter string. There is your radius. If the object completes 9 revolutions every 0.25 seconds, find the period of the object. Okay, so I want to find the time it takes for 1 revolution. Okay, 5.25 seconds is not that time. Okay, I can do 9 in during that time, but I can figure it out by taking my time, 5.25 seconds, and divide it by the number of rotations, and you get a time of 0.58 seconds. So that is how long it takes to do 1 rotation. So that's your answer for A. Now B says, what is the frequency of the object? So remember, frequency equals 1 over T. So I'm going to do 1 divided by 0.58, and that's going to give you a value of 1.72 hertz. Okay, so that's basically saying that it can spin around 1.72 times in 1 second. And then we're going to move on to part C. It says find the centripetal acceleration of the object. So we're looking for AC. Okay, so remember AC equals V squared over R. So if you notice, I don't have V, so I can't really do this. I have R. Okay, so what I'm going to do is I'm going to find V. So we're going to do that over here. So V equals 2 pi R over T. Okay, so 2 pi times your radius, which is 0.60, over your time, which is 0.58. Okay, and we're going to get a velocity of 6.5 meters per second. So now I can do is I can plug that in. So I can take this and bring that over here. So I can do AC equals V squared over R. So V squared, so 6.5 squared over your radius, which is 0.60 meters. Okay, so do your math there, and you should get an acceleration of 70.42 meters per second squared. Okay, so this is what I mean by if you don't have enough to do an equation, You're probably gonna have to use another one to get what you need and then bring it over. And then last bit, find the tension in the string. Tension is a force. Okay, so if you're not sure, take a look at what you've already done. You've already found velocity, you found acceleration, you've got period, you got frequency. The only thing left would be F. Okay, so we're gonna do FC equals mass times AC. So our mass was 0.5, and we found our acceleration to be 70.42. So we're gonna multiply those, and you're gonna get a value of 35.21 newtons. And that'll end that one.